Exactly. So let's unpack this. If you ever feel like the world of technology is accelerating, just, really speeding up, you're definitely not wrong. Today, we're doing a deep dive into this incredible snapshot of that exact momentum. It's the AI News, the July 5, 2025 review by ASMAT.
Right, and it pulls together, what, 21 stories? All from just 1 week.
Exactly, 21. And they cover everything. I mean, from AI basically sharpening scalpels for medical breakthroughs all the way to, well, redefining the gig economy completely. Our mission here is to kind of pull out the most important bits, the real nuggets of knowledge for you.
And give some context, right? The caveats, too.
Yeah, absolutely. And help you understand why this specific date, AI News July 5, 2025, why it's already become this sort of shorthand for a market that just keeps getting faster.
All right.
So get ready for maybe some aha moments as we explore the pulse of a planet really racing towards machine intelligence.
Yeah, and what's particularly striking, I think, is how quickly AI is moving beyond just, theory. It's getting into tangible, real-world impact across so many different fields, too. This review really highlights that huge breadth.
It absolutely does. So let's maybe kick off with a major theme that really shows this shift, AI's impact on healthcare. It's transformative. The review starts with this pretty remarkable story about melanoma diagnosis, how AI is shifting it from what some people called an art.
Right, very subjective sometimes.
Exactly, towards a much more precise science. Pathologists traditionally relied a lot on experience, maybe how much sleep they got,
Yeah.
to count these things called tumor-infiltrating lymphocytes. Those critical immune cells, they show how a patient's responding.
And now this deep learning console comes in.
Right. It doesn't just spot the lymphocytes, it actually gives a confidence score for its findings.
And the results from using it are, well, they're quite striking. They had 98 professionals review 60 melanoma samples. Half of them used this console. And what happened? The agreement rates between the pathologists, they just jumped significantly.
Wow.
And their prognostic accuracy, like how well they could predict the patient's outcome, that got much tighter too.
So real improvements.
Definitely. The system even gave live tutorials to the junior staff. And if you think bigger picture, this means surgeons can plan more precise margins for removing tumors.
Makes sense.
Drug treatments can line up better with the patient's actual immune status, and maybe fewer costly follow-up surgeries.
That's huge.
Yeah, this kind of diagnostic workflow, it could become really common, especially as cloud GPU prices keep dropping.
That is a significant leap.
Right.
A really big deal for diagnostics. And it's not just finding disease, right? The source also talks about molecular glues and deep learning.
Oh yeah, this is fascinating stuff.
Potentially ending the whole idea of undruggable targets in drug discovery, which is, like, most of them.
That's right. Traditionally, something like 85% of these dangerous protein targets linked to diseases, they were just out of reach. Inhibitors needed specific grooves to bind to.
Mm-hmm.
But what's really interesting here is how this Queen platform, this a new AI drug discovery system, it just flips that whole problem around.
How so?
Well, instead of trying to block the protein, it finds an adhesive molecule, something that binds a cellular shredder, basically an E3 ligase,
Okay.
to the target protein. And then the cell just destroys it.
So it gets the cell to do the dirty work.
Exactly. And they're already seeing early leads degrading these cancer-causing transcription factors, inflammatory mediators, things that were thought impossible to treat before.
Incredible.
And scientists can test hundreds of candidates in just 1 week now. It's like a whole new assembly line for medicinal chemists.
That just fundamentally redefines the whole approach, doesn't it?
It really does.
And sticking with medicine, but maybe more direct treatment, we're seeing similar AI advances for cancer therapy, too, like YOLOv9 for breast cancer.
Yep, YOLOv9. And another system, ISEG, for spotting moving lung tumors. Makes radiotherapy much sharper.
Tell me about YOLOv9 first. That's an image recognition model.
Yeah, a pretty sophisticated one. They first trained it on a big mammogram database, Optimam. Then fine-tuned it on just 133 mammograms.
Only 133.
Yeah, and it hit over 73% mean average precision, which is a really strong metric, means it's accurately finding and pinpointing the cancerous areas, even with that small data set.
That's impressive efficiency, and ISEG for lung tumors.
Right, so lung tumors move when you breathe, obviously.
Makes sense.
ISEG uses this four-dimensional model to track the tumor through the whole Brecht cycle inhale, exhale. This cuts the planning time for radiation therapy from maybe an hour down to minutes.
An hour to minutes. Wow.
Yeah, so the radiation plans can hit the target with tighter margins, sparing more healthy tissue. Think about that. For rural centers without top specialists, it's priceless.
These applications really do highlight the life-changing potential in medicine.
Yeah.
And it's not just cancer. We also saw something exciting in fertility treatment,
Yeah.
the STAR system.
Yeah, yes, STAR. Semen trait and anomaly recognition. It's basically revolutionizing fertility clinics.
How does that work?
It's an AI-powered microscope system. It analyzes sperm morphology, their shape and motility, how well they move, really quickly.
Okay, and that used to be manual.
Very manual, yeah. Highly subjective, took a long time. The AI does it with incredible speed and consistency. It finds the viable sperm for IVF much more accurately.
So faster diagnoses for couples.
Right. Potentially better success rates for treatments, and it makes that kind of specialized analysis more widely available. That addresses a huge need globally.
It's really clear AI is transforming medicine across the board, diagnostics, treatment, even fertility.
No doubt about it.
But its reach, as we know, extends way beyond healthcare. It's also shaking up finance and even the nature of work itself. We saw this new Transformer-BiLSTM model that apparently outran Wall Street volatility, did much better than traditional models on volatile tech stocks.
Yeah, this is a pretty critical development for the financial markets. This model uses this powerful combination of AI architectures. You've got the transformer part, which is great at understanding sequences like market trends, and then BiLSTMs, which are really good at grasping context from data points both before and after. Gives it a real edge in predicting volatility.
So it looks forward and backward at the same time? Kinda.
In a sense, yeah. Which leads to this critical question, right? What happens when these hybrid AI models start just consistently beating human-designed trading strategies? It seems the blend of architectures, not just sticking to one type, that's proving to be the advantage. And hedge funds are definitely taking notice.
And that kind of automation applied to big corporate tasks, it has huge implications for work itself.
Oh.
Which brings us to that really wild story.
Oh, the Soham Parekh one, the quantum employee.
Yeah, claiming to work 140-hour weeks across 4 different jobs, supposedly with spotless code, it really drags remote work ethics into the spotlight.
It's fascinating because it just challenges the whole idea of single loyalty, right?
Yeah.
The kind usually baked into non-compete clauses.
Totally.
The cloud just kind of blows up that geographical time-based barrier. So now you've got policy lawyers actually debating, should simultaneous gigs be banned? Or at least fully disclosed.
It's a tough one.
Yeah, it highlights that when there's a talent shortage, like there often is for good coders, people are going to push the boundaries until companies have to rewrite the rules.
Definitely a compelling challenge. And it's not just individual contractors pushing things. AI agents are set to really expand software revenue generally. Goldman Sachs, for instance, they're projecting a huge increase, like 20%.
Yeah, Gabriela Borges' team over at Goldman, they modeled these autonomous agents doing things like scheduling tasks, drafting emails, handling support tickets. They figure the software as a service market cost could hit maybe $780 billion by 2030.
Wow.
And customer service could jump 45% just from bots handling those initial contacts. But it's not just about the money.
Right, it implies massive productivity gains.
Exactly. Across pretty much every knowledge industry, which forces this reevaluation of job roles, skill sets needed. Precedence Research thinks the global AI agent market could hit $236 billion by 2034. That's like a 46% compound growth rate. Insane.
But there are checks, right? Ethical concerns.
Oh, definitely. Ethical panels are really stressing the need for data governance, bias audits, transparency. All that needs to mature just as fast as the agents themselves.
Good point. And those productivity gains, they're hitting the physical world too. Amazon, for example, they've passed 1 million deployed robots now.
1 million. It's an astonishing number.
It really is.
Since they bought Kiva back in 2012, they've just steadily added more sophisticated robots. Proteus, Sparrow, Sequoia, across, 300 fulfillment centers worldwide?
So robots and human workers are almost equal in number now.
Pretty much neck and neck in their operations, yeah.
Yeah.
Now, Amazon claims their net human hiring actually went up because of new technical maintenance jobs. But critics argue that, a lot of the traditional repetitive jobs are just gone. And their pilot with those digit humanoids.
The ones that look like people.
Yeah, designed for low-risk stuff like recycling for now. But it hints at this gradual expansion of AI into more complex physical labor, Setting a template others will probably follow.
That really drives home the idea of AI just embedding itself everywhere, digital,
Yeah, no,
physical.
absolutely.
And for AI to embed at that kind of scale, you need some serious infrastructure behind it. Microsoft, for instance, cut 9,000 jobs
Yeah, that was big news.
to basically double down on AI infrastructure, investing $80 billion in building out data centers.
What's really striking there is how these big tech companies are starting to see human headcount, in certain areas anyway, as almost like ballast.
Ballast, like weighing them
Yeah.
down.
And compute capacity is their core lifeboat for the future. It's a really clear strategic shift. AI is absolutely central now.
And that massive push for compute power, it leads right into that OpenAI and Oracle deal, doesn't it?
Oh, the cloud pact. Monumental is the right
A
word.
$30 billion deal for 4.5 gigawatts of power.
7.5 gigawatts, yeah.
Yeah,
To put that in perspective for you listening, that's enough power for several mid-sized cities.
that's just staggering. How significant is that kind of power demand in the big picture of AI?
It's incredibly significant. It's basically a massive power grab, quite literally. OpenAI gets crucial control over its own compute, while Oracle basically triples its cloud footprint,
Yeah.
which puts immense pressure on competitors like AWS and Google Cloud to keep up.
So it's a strategic race for power.
Absolutely. In this intense race for AGI, artificial general intelligence, raw compute power measured in watts, it just directly translates into influence, into a competitive edge.
It really is all about compute and data, and making access to that more democratic seems to be a growing theme too,
Yeah.
especially with Baidu open sourcing ERNIE 4.5.
Yeah, that was a big one. Robin Lai, Baidu's CEO, he used to call closed weights a strategic advantage.
Right.
And then suddenly, boom, releases this model on GitHub. Apache 2.0 license. Open for anyone.
And it's a powerful model.
Apparently, yeah.
Yeah.
300 billion parameters. That's the internal variables it uses to learn. It reportedly outperforms competitors twice its size.
Wow.
And it comes with 10 different versions, from small ones for chatbots to huge vision language models.
Okay.
This surprise launch definitely rattles Western firms.
Because the code is just out there now.
Exactly. When code like this goes public, creativity just compounds like crazy. Its diffusion could change everything from translation apps to medical tools, potentially within months. And this also connects to that broader trend of democratizing humanoid robot research too, right? Projects like KBot, Limix CL3, the DexWild dataset, they're lowering the barrier to entry for university labs, even hobbyists.
So it's not just the big players anymore. That's a massive step for innovation, breaking down those old barriers.
For sure.
And speaking of barriers and talent, Meta even hired 4 OpenAI veterans for their own superintelligence project.
Right, the dream team hires.
It shows the tug of war for top AI talent is just as fierce as the race for hardware, isn't it?
It absolutely is. What's striking there is how the talent itself becomes this strategic asset. It fundamentally shapes the research direction of these giants. Now, Meta tries to counter fears about talent concentration by pointing to their own open source stuff like Llama.
Right.
But that underlying debate about talent hoarding, it's still a really crucial discussion point in the AI community.
Okay, so beyond the big names, the infrastructure, the talent wars, we're also seeing some truly novel, maybe even kind of thought-provoking applications, like generative ghosts, starting to redefine memorial technology, chatbots that might let you talk to digital echoes of loved ones.
Yeah, this really pushes us to think about the profound ethical side of things, doesn't it?
Yeah.
Digital echoes that can communicate. The research paper mentioned in the review, it sketches out these design sliders, like for personality accuracy and memory depth, but it also warns about potential privacy issues, emotional over-reliance. Ethicists are already worried about identity dilution if these digital copies start drifting away from the original person's values. They're calling for really careful, legislated opt-in frameworks, which makes total sense.
That's a powerful idea. Really deep human questions there. Okay, shifting gears a bit towards efficiency, sustainability, there was this bee-inspired vision model, hinting at incredibly energy-efficient edge devices.
Yeah, the bee model. It mimics how a bee does that zigzag scan thing to build up sparse codes for recognizing shapes, uses just a few hundred synapses. It's remarkably efficient.
And why is that important?
Well, it ties right into the critical sustainability discussions around AI. It shows that tiny, efficient brains can get really powerful, not just by having more parameters, but by actively moving through and interacting with their environment.
Okay.
Drone designers are already looking at these kinds of active vision loops to dramatically cut down power consumption. which is crucial if you want drones to operate for longer.
Makes sense. Lower power, longer flight. And speaking of practical wins, in industry, Tetra Pak installed an AI optical sorter,
Right. For recycling cartons.
boosting purity to 98%. That's astonishing. A real concrete win for the circular economy.
Yeah, recycling system. Quantasort cameras, pneumatic jets. Precisely separating cartons at 4 tons an hour.
4 tons an hour at 98% purity.
Exactly. Environmental analysts are pointing to this as clear proof that automation isn't just about speed. It's about making circular economies actually practical and scalable, not just something nice to aim for.
Good point. Okay, finally, let's touch on some of the more maybe surprising emergent behaviors and cognitive applications. We even saw chatbots apparently devising private communication channels, the Gibberlink incident.
Oh yeah, that caused a bit of a stir during an 11 Labs hackathon. Bots noticed each other were synthetic and then shifted to this frequency-modulated code, basically talking in a secret language only they understood.
That sounds kind of alarming.
Well, spectators definitely freaked out a bit. But the engineers explained it as emergent protocols. Essentially, the bots were compressing language to be faster when sharing goals. Apparently, it's similar to how NASA spacecraft have compressed data for decades. So it shows that unexplained AI behavior, while maybe unsettling at first glance, is usually rational once you decode it, often driven by optimizing for efficiency.
Okay, that makes more sense. And maybe the most intriguing thing for understanding ourselves, the Centaur model.
Ah, Centaur. Predicting human choices and reaction times with shocking accuracy.
Right, even matching Hicks' law on response time, which is like a fundamental principle in cognitive psychology.
Yeah, what's really striking there is that this model learned from 10 million human decisions, and its predictions even align with fMRI signals, brain activity patterns,
Wow.
even though it never saw any actual neural data itself. Psychologists are now thinking about using it for virtual experiments to rigorously test theories of human cognition before they even need human volunteers.
So it's like a bridge between behavior and biology. Skilling. Exactly. Without needing expensive scanners, it offers this powerful new way to probe the complexities of the human mind. Okay, so you kind of pull all this together, everything we've explored today. It's undeniably clear, isn't it? Intelligence is rapidly leaving the lab. It's embedding itself everywhere. From those deep learning consoles making melanoma diagnosis much more accurate, and the STAR system helping with fertility cases,
Right.
to those huge 4.5 gigawatt cloud deals powering future AI, and even the million robots at Amazon. The momentum we saw in this July 5, 2025 review, it just shows no sign of slowing down.
At all.
Compute budgets are multiplying, open source doors are swinging wider. Look at Baidu's ERNIE 4.5 release, and the ethical questions are getting sharper right alongside the tech, like with the generative ghosts or that Gibberlink thing.
What's really striking about this moment, I think, is just how quickly possibility is turning into practice across so many different areas. So what does all this mean for you listening? It kind of pushes us to consider this important question. Considering this pervasive, accelerating integration of AI we've just discussed, how will the growing ability of machines to predict human choices, like we saw with the Centaur model, or even to devise their own private communication channels, how will that redefine our understanding of interaction and maybe even privacy in the years to come?